All right, in this example, we're given the formula for a function, and we're asked to sketch the graph and then find these limits. We want to look at the limit as x approaches 1 from the left, from the right, and then if they match, then we can find the limit as x approaches 1. Okay, now if you look at this formula, if you try to plug in x equals 1, you'd see we have a problem because the denominator would be 0. 1 minus 1, the absolute value of that is it's just 0. We can't divide by 0. So we're going to have to figure out something else to do here. So the first thing I'm going to do is just factor this and see if I can simplify it at all, right? So I can factor a 2 out of the numerator, right? And I'll get x squared minus 3x plus 2, right? And then I'm just going to leave the denominator as it is, absolute value of x minus 1. Oops. Let's make that a absolute value. All right, and then I can factor that quadratic, right? So I get x minus 1 and x minus 2. And then I still have the absolute value of x minus 1 in the denominator. All right, so now you can see we've got an x minus 1 in the numerator and the x minus 1 in the denominator, and that makes me want to say, okay, maybe we can cancel those as long as x isn't equal to 1. But because we have that absolute value in there, we have to be careful because sometimes what's inside the absolute value could be negative, and then we need to change the sign of it. If it's positive, we really don't need to do anything to it because the absolute value just makes it positive. And if it's already positive, then we don't need to do anything to it. So we need to break this down into a couple different cases depending on what's happening with x minus 1. If x minus 1 is less than 0, then we have to change the sign of it. So I'm going to rewrite this function as a piecewise function. All right. So let's draw a little bracket here, and we need to look at what happens when. Well, let's look at what happens when x minus 1 is less than 0, which means x is less than. Let's do x is less than 1. Okay, so for x less than 1. We'll look at the case for x greater than 1 and then x equals 1. Okay, I'm going to break it down into a piecewise function. All right, so if x is less than 1, right, then you can see the x minus 1 will be negative up here in the denominator. All right, so I'm going to rewrite this for this is the case where x minus 1 is less than 0. X minus 1, x minus 2, and if x is less than 1, then x minus 1 will be negative, and we have to change the sign of it. So to change the sign of a negative, to make it positive, we're going to take the negative of a negative, and it'll look like this. Okay, this is for x less than 1. Okay, this is the case for x less than 1. And then you can see, well, we can just cancel the x minus 1 as long as x is not equal to 1. And we'll end up with a negative 2 times x minus 2. Okay, so that's our formula for g of x as long as x is less than 1. Okay, now if x is greater than 1, then what do we have? Let me see. I guess I should have left some more room here. If x is greater than, if x is greater than 1, then we don't need to change the sign of the denominator, right? We have x minus 1, x minus 2, and then the x minus 1 will be positive, and we don't need to change the sign of it, so we could just cancel it. And this will be for x greater than 1. All right. So kind of messing up my graph here, but that's all right. So what do we have? What we have left is 2 times x minus 2. Okay, so that's what it simplifies down to if x is greater than 1. And when x is equal to 1, it's undefined, right? It's undefined, so it does not exist. I'm just going to write undefined for x equal 1. Or x equals, sorry, that should be x equals 1, right? Because that's what we're looking at. X equals 1. All right, so let's graph what that looks like. Now, these are just a couple of lines, right? I could distribute that -2, and it would be -2x plus 4. Okay, so when x is less than 1, it looks like a line that has a slope of -2 and a y-intercept of 4. So I'm just going to draw what that looks like. Now, at 1, it's actually undefined, so I'm going to put an open circle. Now, it would, you know, if I could go if I could go to 1 and use this formula, I would get a +2, right? If I plug in 1, I get -2 times -1. And so it looks like it would go to 2, but just by this piecewise definition, I can't actually go there. That's not a great line, but you get the idea. That should be a straight line, right? Let's see if I can draw it any straighter. I don't know. All right, that's good enough. All right, so there's part of the graph when x is less than 1. All right, now when x is greater than 1. All right, now we have a different line. If I distribute this 2, it would be 2x minus 4, so it's a slope of +2 and a y-intercept of -4. And I don't have -4 on the graph here, so we'll have to put in some points. All right, now if we were to put in 2, then we get 2 times 0, so this would be on the graph, and it's going to have a slope of 2, so these points would be on the graph. Now, at 1, if we could go to 1 and use that formula, we would get -2. All right, but we can't, it doesn't actually include that point, so I'm going to put an open circle there. And now I'm just going to connect these points. All right, with a semi-straight line, as straight as I can get. Okay, so pretend that's a straight line. All right, so that's what my graph looks like. It's just two straight lines, but there's a problem at 1, right? This function is undefined at 1. Now, if I approach 1 from the left, you can see it would approach 2, right? Because if I put in 1 into this top formula here, I get -2 times 1 minus -2, so that would be a +2. So, but it looks like it's going to 2, right? I can get as close to 1 as I want from the left, and it's going to get closer and closer to 2. I just can't actually go to 1. And from the other side, right, I can approach 1 from the right, and it looks like it's going to go to -2, right? If I put in 1 into the second formula, I would get -2. It's just that I can't actually go to 1. It's not defined at 1. Okay. Now, the left and right-hand limits don't match, so we say that the limit as x approaches 1 does not exist. Okay. So the left and right-hand limits exist, but the limit as x approaches 1 doesn't exist because those left and right-hand limits do not match.